I try to withdraw you a little bit to a different subject. We go back in history, we leave the Himalayas, or we go to the European Himalayas, whatever you like to call them, and we will focus at the beginning on one event on June 16, 1818. You may ask yourself the discovery of the Ice Age. What's going on here? We know there is an Ice Age, and we are right now in the middle of an interglacial period within the Ice Age. But think back 200 years ago. Nobody had an idea of an Ice Age. That was a different world. There are a few points of discussions this afternoon. I would like to talk a little bit about man in the mountains. It's very the same thing back home as it is here. There are mountains, there are people living there. Then the glaciers and the little Ice Age. Then comes a name, Ignaz Venetz. He was a civil engineer, and his activities were related to this June 16, 1918. Then I want to put this in a little bit broader aspect, and we look at 10,000 years of glacier oscillations, and a little bit on new lakes, and then maybe I will find a few points I would like you to remember. Now, that was the old time, 200 years ago, before 1800. Of course, there was a world of glaciers, but that was far away. It didn't matter to people in the populated area of the country. If there are people high up in the mountains and they know about glaciers, so what? They are there. We are here. So, and where we go is quite simple. We go to this part of the country, Lake Geneva here, Bern here, Lake Constance over there, Milano down here, Mediterranean Sea. So that's the area we will be looking at a little bit closer. Now, man in the mountains. There are three aspects I would like to mention. Man started to move around in the mountains since the Bronze Age. He was hunting and farming. And you know the name of Ötzi? Ötzi and Company, you know. There was not only one Ötzi, but the most spectacular one was found in Austria. That's why he is called Ötzi. There were other places where Ötzis were hanging around. So that was the early phase. And here comes a very important consideration. The settling of the high Alps was not through the rivers uphill. The settling and migration into the high Alps above tree line was through the high mountains, through the high passes from the south. That's where you can move easily. You don't have to go along these rivers where it's dangerous, where there are bears and other dangerous things. You move in the open landscape high above. So that's why I think there is some kind of an understanding of people in the Alps, because that's their background. That's where we were moving many, many hundreds of years ago. And then the Romans. The Romans, that's fascinating. You all know Hannibal was crossing the Alps. Maybe it's true. Maybe it's not true. Maybe it's a good story. But it's a good story, of course, so we leave it. It's difficult to find archaeological evidence, but it doesn't matter. And the Romans were also moving across the Alps, south-north, north-south, with armies, with goods. But in all the travel accounts of the Romans, there is not a single mentioning of glaciers. Even if the glaciers were moving later on, or so closer to the passes where the Romans were crossing. So there are only two options. Either the glaciers were smaller at the given time than today, or the Romans were traveling only at night. With the Romans, increasing traffic occurred in the Alps, increasing population, and during the last 100 years, we really increased the infrastructure, made it sensitive to very small rocks falling down. These are just illustrations to Ötzi and Company. These are artifacts from Schniederjoch, that's in the area of canton of Bern and Wallis 5,000 years ago. That's part of a Stuhl. found up there, which was melting out underneath the small glacier. And that's an interesting thing. This down here, over there, is a corner glacier, and this is an old pathway with steps artificially put in. And this pathway was partially covered and destroyed by the Little Ice Age re-advance moving against us. So, before the Little Ice Age, the people were moving to the corner valley with their cattle. Now we come closer to the Little Ice Age. The Little Ice Age, or what is called, and I'm referring to the discussion by Jörg this morning about Little Ice Age, medieval warm period, what is a fact is that during the years 1315 and 1322 in the Alps there was a severe time of famine. And that was the onset of a period, climatic period, with colder phases, and it went on for about 600 years with 3 major cold phases, and with glacier advances down to the passes. And during this time, especially during the last major phase of the Little Ice Age, men realized glaciers can move closer to where we are. So they can be closer to the main centers along the border of the Alps, and so on. However, there was in the old church books a record of 15th of May, 1595, that the Glacier de Gietroz already caused a lake to be dammed by a regenerated glacier, and it was a very serious situation down valley. But it is written in the church books. It was still the responsibility of the church, 1595. There was nothing else behind. God had to punish these guys in this valley. They didn't behave, so they are flooded out. The combination of processes in the valley came later on, came about around 1800 up to 1818. This is a drawing, beautiful drawing, of the Mauvesin Lake in early 1818. You see the Glacier de Gietroz descending, regenerating a huge, big ice dam and blocking an up-valley lake. There were more glaciers to come down and joining in. And you realize here, there are obviously visitors standing here and debating what's going on. There were more people around here. So that was the situation in early 1818. And because there was still some kind of a memory, because it was written in the church books, things can happen up there. So the Canton of Wallis commissioned Ignaz Svenetz, the engineer, to solve the problem, to prevent a problem. He went to visit already in 1811 the Val de Bagne, that's the area up there. 1811 to 1818, the glacier advances, and the riverbed is over most of the time, completely dry. On May 13th, 1818, they start cutting a channel through the glacier. On June 13th, 1 month later, water flow through the channel starts. June 16th, only 3 days later, lake level is down by 9 meters, and the underflow underneath the ice barrier starts, and springs start to appear down valley of the ice barrier. And that was it. Within hours, the ice barrier burst and flooded the valley. And it looked like that. That's a drawing by Alfred Escher von der Lind. Afterwards, you see the cut in the ice barrier. You see there is still a lake here, but at a lower level. Now, just briefly, the situations. Here is 1818 to 1823, the Glacier de Gietroz, high up, and here the ice barrier. Here the channel they were digging, here extending the leftover lake after the ice dam broke. And interesting is here, these number 3s, these people were collecting springs outside of the ice barrier of the lake and brought in the water into the channel because this was a little bit warmer water, it was spring water, to prevent the channel from freezing over. Today the situation, 1981, a beautiful arched dam was inaugurated, and now we have the Lac de Moisin as a power lake. Today it looks like that. I like this picture, this is so beautiful, you know. Glacier de Gietroz. Down here the lake today, and the arched dam is exactly there, where there was a regenerated ice dam 200 years ago. That's the Moisin story. Now, why is this so important? Ignaz Venetz and June 16. Ignaz Venetz was a brilliant person, just absolutely brilliant. So, what did he do? He did careful observations of an area, and he did record carefully ice advances. Then he had a friend and mountain guide, Jean-Pierre Perrodin. He is actually the big person. He made observations, and he followed the philosophy of common sense. Glaciers are moving. They are moving forward and backward. It's natural. In 1822-29, publications by Ignaz Venetz on the oscillations of glaciers. In 1841, the first map of a paleoglacier to the foreland, which was the product of discussions with Ignaz Venetz and Jean-Pierre Perrodin up there in the mountains. So this event, this tragic event, actually, and the observations around it, brought up the idea glaciers are moving. They don't stay forever in the high Alps. They may move to the foreland, as was proven in this small place up there. And that's when the idea of an ice age was born. Now, just looking back, the Val de Bagnères, Gloff events caused by Glacier Gietroz, the early one, only recorded in the church books, 1595, 140 casualties, 400 houses that cleaned out. The valley was more or less clean. The other one, June 16, 1818, 44 casualties, dozens of houses just cleaned out. Now another one. I think you like this photograph, you know. It's from 1822. There is a lake, there are glaciers damming that lake, and there are people around here and animals. So man in the Alps was accustomed over centuries to live in this environment and to live in vicinity of glaciers distending from lateral valleys, causing the damming of a lake. Now we move on and look at this glacier in the last century. It's a glacier, it's the Alaline Glacier. You see the glacier, 1952, it's the Ice Age moraines. It's hanging up here on bedrock. And August 30th, 1965, the whole thing collapses, killing 88 people down here. Why? There was the installation, or construction site installation, to build a power dam, to build an earth-filled dam right here. The dam has been built since, but it was another lecture that things can happen. Now, when did it happen? This is too complicated, that's where the glaciers were all about, but I like this diagram. Time here, this is 1960, 1970, and at this point, the glacier collapsed. You see, it was during a re-advance phase. It was during the most recent re-advance phase that the glacier actually came to a certain point, got unstable, collapsed, and re-advanced further before it started to retreat. So that was an example of, again, of an accident during re-advance phase. Another one, Altelsberner Oberland, 1991, beautiful photograph, famous ski area for summer skiing and so on. And if you go back, 1895, 120 years ago, there was a very, very bad collapse of the glacier, just slipping down here, destroying a whole settlement in the high Alps and running up on the other side, upslope. killing several people, cleaning out hundreds of cattle, and so on. Again, this one here, in a small re-advance phase, overall retreat, just a small push for about a few years, and the whole thing gets unstable and causes a problem. So, these are a few examples to show that there were problems in the Swiss Alps. There's a long list, there is a full record, a full archive of such things back home. Now, just to put it in another scale, we look at these 10,000 years of alpine glacier oscillations, and my main point is that I would like to show you how sensitive and dynamic systems alpine glaciers, valley glaciers can be. Mainly controlled by climate, precipitation, temperature and precipitation, and local topography. That's one of the photographs. It's Zermatt, it's Finland Glacier at Zermatt. Beautiful little ice age moraines, so on. Here's a glacier. A simple situation. So, but this here is a sedimentary basin. There is some information down there. And if we look at this outer part of the moraine ridge, we see this. It's not a simple moraine ridge. It's a complex set of ridges with glacier advances and retreats. But where were the glaciers in between? They advanced, went back, but how far? Well, so on. So, last 10,000 years, this is an old curve. I like it so much because it's so simple. It's a Camp Century ice core record, and it shows about 10,000 years with 8.2, apart from the 8.2K event, it shows a very monotonous climatic signature. Over to the right, Stein Glacier in the Central Alps, and here you see a little moraine ridge. That's the most recent moraine ridge produced by this glacier in 1990. Since then, it has retreated. There is no ice visible over here. Now, this aspect we have just seen belongs to this phase here. So 2000, looking back in time, we have this period between the 1960s, 70s to the early 90s, advancing glaciers before retreating glaciers in red. In the 1920s, advancing glaciers before retreating and advancing, and then we go into the Little Ice Age. So that's the short-term record of about 150 years based on measurements. Now comes something else. This here is a glacier, a beautiful glacier core, beautiful chaos. And here, a beautiful tree and my chainsaw. Very simple situation. You see it's about 100 meters from the glacier, Glacier de Momine, a neighboring glacier of the Glacier du Gietroz in the valleys. These pieces of wood being transported out of the base of the glacier show enormous characteristic high compression deformation, or they show most beautiful polish on the surface caused by movement of the ice. And then in here, these polished logs with small pieces, small pebbles, small pieces of rocks, heavily pushed into the wood. And these are then the big surprises if you arrive with your chainsaw. So we have collected up to now way over 3,000 such samples. Compressed peat, such logs, beautiful. We have dated somewhere between 150 and 200 by radiocarbon, the same amount by dendrochronology. And the interesting thing is that the radiocarbon dates do not just form a cloud on a time diagram, but if you put them on the radiocarbon calibration curve, these dates are placed on the plateaus. It goes with the de Vries effect, and it shows nothing else but that the sun is playing its role in the times when the trees were growing or the peat was growing, where the glaciers are now. This is the resulting diagram. Time here today, last 2,000 years, we have not many samples at Holzhauser's realm. And then further south, you see there are time periods with many, many samples. Many samples. Some samples. Many, many samples. And so on. And we have reconstructed a banded times, so to say, in yellow, in blue, in yellow, in blue, in yellow, in blue. In between, where it's blue, no samples at all, until now, I must say, of course. But from this we conclude that there were times during the Holocene that glaciers were smaller than 2005 when we all started this, and that there was vegetation growing underneath in the valleys where there are glaciers right now. Here, the valley of the Glacier de Momide, that's a glacier with a chainsaw that was down there in 205, beautiful glacier and so on. That was the extent in 1991 down here. And then I have tried my artistic view of the mountains 8,400 years ago. That was the valley at that time. The end of this beautiful period up there was the 8.2K event, because we have a large number of logs which were killed, or the trees producing these logs were killed within 3 years, in 8,200 years ago, plus minus 3 years. Now, the reference point for all these considerations is, of course, the LGM. And I just want to show you briefly the most recent map of Switzerland of the last glacial maximum. At that time, 75% of the country were covered by ice. It's a big change towards today. During the most extensive glaciations, 5% were not covered by ice. So, it's the Alps. I don't go into the details. There are interesting reconstructions of paleo precipitations. Now, very shortly, just to show you that we have the same problems as you have, these new ice contact lakes are formed with the most recent glacier retreat and down melt. Now, I think there are very few points to remember. One is, of course, that we try to look back. There is a history on glacial investigations in the Alps. There is an intricate history of living of the people in the high mountains with the glaciers. Very intricate. They are there. I am there. So I have no choice. We are both here. And if we want to live, we live here. So, a little bit tragic thing is, of course, that events or accidents have to bring glaciers to public attention. But this is always the case for a human brain. It only works if it's pushed or smashed or something like that. So, yes, that's how it works. And we must see, the idea of an ice age was not an academic, the result of academic thinking. It was the idea of field observations by a hunter in the Alps, by a civil engineer, and by the director of the mines in Bed. Then the last phase of the Little Ice Age, 1780 to 1850, initiates, then as a consequence, engineering and scientific awareness with regard to glaciers in the Alps. So the engineers became a little bit more important, and the church had to step back a little bit. Except one thing. In 1850, the Glacier de Vierge was advancing, and the people in Vierge were endangered and were afraid. The glacier was overrun the village. So they asked the Pope if they would be allowed to do a celebration to prevent the glacier from further advance. The Pope said yes, do it. He sent a representative. The glacier came still a little bit, but it's okay, it stopped more or less. Now, it's the other way around. 5 years ago, they asked the Pope again, can we have a celebration to get the glaciers coming again? Then the Pope had to think and discuss it with his advisors. Can you change such a basic rule from positive to negative? It took the Pope 2 years to agree, and now they had a ceremony to ask the glacier to come again. That's in the canton of Valais. Then, I think this is important too, both for engineering and science. There is one crucial aspect. Of course, this is my personal view. Okay, please forget it so immediately if you don't agree. Field work is crucial. Monitoring, surveying, mapping, history of these events, and ice rock interactions. Most cordial thanks for your invitation and attention. Bye-bye from the Matterhorn. Thank you.